Okay, so let's start. Hi, everybody. Welcome. I am Nancy Irizarry-Mendez. I will be joining the organization of PyLadies Amsterdam in the coming weeks. For today's session, we will have 3 speakers. Each of them will talk about how they use Python in their careers to help cure cancer, to explore the birthplaces of stars in the universe, and to predict if customers will leave a service. Some house rules before we begin. Please mute yourself. You can make questions via the chat. Somebody might answer them during the presentation, and otherwise at the end of each presentation, we will have a question and answer, a Q&A minutes, around 5 minutes. So feel free to use both of those opportunities to make your questions. It's nice that you make questions, so go ahead, don't hesitate. So let's welcome on stage Parimala Devi. She's a bioinformatician who programs with Python. Sorry?
Yeah, just a minute. Yeah.
She's getting ready. She's a bioinformatician. She programs with Python at the Netherlands Cancer Institute. If you can let us know when you're ready, Parimala. So greetings from Hamburg, Germany. In the chat, you see.
Okay. Is this good? Can I?
Yes, you can start. We can see you.
Yeah. Hello, everyone. I'll be talking a little bit and giving an introduction to using Python in bioinformatics. So it's a very, very basic introduction to bioinformatics as well. So I am Parimala Devi, and I originally come from India. And I am currently working as a bioinformatician in the Netherlands Cancer Institute. And I have done my master's in bioinformatics from Georgia Institute of Technology, Atlanta, the USA. And after that, I have worked at around 3 or 4 other institutes and industrial companies. And I'll be talking about them later on as in the talk. So let's start. So the first question everybody does ask is, what is bioinformatics? Because not a lot of people know or understand what it means. They understand there's some amount of biology in it. And so the first thing that comes to my mind is explaining through this Venn diagram of it being an interdisciplinary between biology, statistics, and computer science. And the next thing people ask is, do you need to know all of these to become a good bioinformatician? Well, good knowledge of all of them is not an absolute necessary. At least 2 of them, yes, that would help you have a higher upper hand in understanding the questions and what needs to be solved. Okay. So as you might have known that with respect to bioinformatics, the number of languages used are not a lot, but there are quite a few of them. And one of the old school languages that have been used for bioinformatics has been Perl. And it's one of the languages I learned in grad school as well, even though back then, back in 2013, Python was the new language for bioinformatics. The academia was not ready to teach Python as a part of the curriculum in grad schools, rather than they were like happy to stick to the good old Perl and Shell. And obviously we have different statistics languages such as R and MySQL. And over the years, we have seen a huge growth in the use of Python for statistics, as well as just as a language to code bioinformatics in. And we have seen that in certain fields within bioinformatics that with applications of machine learning and artificial intelligence, it's so much more easier to use Python rather than any of these other languages. And we've seen that there are so many different algorithms and packages of Python that have come out, which are slowly replacing the R packages. And even though it might not be an end to R, it's absolutely something that Python has been taking over in the recent past. So the next question would be where to start, as you might be new to bioinformatics, either as a biologist or new to bioinformatics as a programmer, or absolutely new to bioinformatics, completely different field, and you're just fascinated by some research you saw and now you want to get into it. So if you're a programmer, as so you do have an upper hand of knowing very important, a good open source tool, and you understand computer science and data structures, and you know how to manage memory and to write good, efficient code, then that is quite easy. All you have to do is understand. You technically do not need like a super understanding of the biology, as long as you get a good description of the problem that needs to be solved, and you are supplemented with sample inputs and outputs to test your code. Well, but as a biologist, when you're new to programming, it does seem a bit daunting that you would have to start coding from scratch, and you do not understand where do you start from. And but you do understand that what the question and what the problem is, and it's easier for you to write out a pseudocode, and then you can slowly implement that in a language such as Python, which is clearly not very hard to learn. So I would say the resources for either a bioinformatician, for either of you as a programmer or a biologist to get into bioinformatics would be, the most basic thing would be to start off with a Bioinformatics and Python book, which you can easily find online. And I totally understand that the amount of resources available, be it articles, be it YouTube videos and online courses, daunting, and you would be confused, where do I even start? So a simple Bioinformatics and Python book is a good starter. And there are a lot of Coursera courses on bioinformatics, and I guess there are some really basic introduction to bioinformatics in Python. I think one of them is from University of San Diego, and they have a University of California, San Diego, and they have a really good 4-week course for Python and bioinformatics. And I feel that's a very good starter, where you do have an interactive session. And then sometimes what happens is, once you've learned a course, you assume you know everything, but the next step would have to be to keep solving questions. And for bioinformatics, Rosalind, HackerRank, and Project Euler are like the top options for you to look for questions. And for me, personally, I have used Rosalind, especially when I started to switch to Python from Perl. That was a very easy way of understanding Python and using all bioinformatics questions. So they start off with very simple bioinformatics questions for you to use in any language, and you can choose Python. And there are a lot of people that would be solving the questions as well. So there's a huge community out there where you can discuss how to solve and all your questions. And there are other websites such as biostars.org, which is one of the best for bioinformatics questions and doubts. And there are really good people out there who try to help you solve your questions and guide you in the right way. So this is a simple thing which I've titled as different fields in bioinformatics, but it's mostly the different fields I have worked in the past in bioinformatics, and I thought this would be a good idea to good way to just tell you how and what can you expect in this field and where are the reaches of bioinformatics. So, and to start off, it would be a clear demarcation of either you work in the industry or you work in academia and research institutes. And one of the fields being precision medicine, where I had worked at the eMERGE consortium in as a part of the NIH, and where the consortium is for electronic medical records and genomic network, and it's a part of the National Institutes of Health, NIH. It was funded by them, and the idea was to develop and disseminate and apply approaches to research that combine electronic medical records, EMRs, systems for genomic discovery and genomic medical implementation research. So here we worked towards using the electronic medical records of the patients and trying to find solutions to help them in help the doctors provide precision medicines for a particular patient based on their diagnosis. And that's been a very happening field in the past 10 years now, for every patient to get a personalized precision medicine rather than generic medicine for their disease. The next would be an industrial approach, where which is drug discovery. I worked at a pharmaceutical company in India called Jubilant Biosys, where they work on producing different drugs. And I worked in the research and development team there, where we were working towards biomarker identification using gene expression, where we applied different bioinformatics algorithms to breast cancer data. And we also were working on using different machine learning and artificial intelligence approaches to predict the different biomarkers that can be identified. So this was one of the industries, this is one of the industries where we see a lot of application of deep learning and machine learning in the field of bioinformatics. And another option is to work at CROs, where you have different universities and academia labs do not have the opportunity to hire a bioinformatician. So then they reach out to different companies who do the bioinformatics part of their research based on the explanation provided to them by the biologists and the PIs in the universities, and then they do the downstream analysis of the provided data, and this way you get an exposure to different kinds of data from different research institutes, and also get to learn different ways of analyzing data. And I worked at a CRO in Finland called Genevia Technologies, where I worked in the research and development team, where we were building pipelines for the analysis, various analysis of different sequence types in NGS. And I currently work at the NKI, the Netherlands Cancer Institute, in the clinical diagnostics department, in the pathology department. So this is the closest you can get to actually having an influence on a real-time patient, because the research we do, the analysis we do is of a cancer patient, and we get the samples from them on a particular panel for a particular cancer type. And we then create pipelines and run pipelines to analyze the samples provided, and then we give the results of different mutations to the doctors, who then make their diagnostics, make their decisions on how to go about with the next steps for the patient. So I guess this is the closest you can get to helping somebody in real life. So yeah, these are the fields that I have worked on, and there are many more different ones with bioinformatics, but yeah, I guess this is mostly what I have, and if you have any questions, please feel free to ask.
Thank you, Parimala. So if there are any questions, go ahead. Super interesting topic. I think I went once to the Netherlands Cancer Institute. I had a meetup there, and it was such a great opportunity because I was like inside the building. I guess it's where you work when you go to the office. And they had this talk that they were doing, I believe it was like image recognition on images that are used for detecting cancer on patients. It was very interesting.
Yeah, sounds fascinating. Yeah.
Yes, it was. Does anybody have any questions?
So I have one question that's maybe a little unrelated, but also a little related. So you said you started off with industry and then went a little more into academia. So how did you make that decision, or what spurred on that decision? And I was also a bit confused about what CROs are.
Sure. Yeah. So I initially started working in the academia, and I worked there for like two and a half years, and then switched over to industry. And so I wanted to see like what's there in the other industry, because people either just stick to one and never leave. I figured that there is scope for research and scope for non-research work in both of them. So it's never that you cannot do research work if you are in an industry. It all depends on the kind of company you go to and the kind of teams that are present there. And CRO is basically a company that provides solutions to any kind of research solutions to any kind of questions you have. With respect to the bioinformatics company I worked, we always got clients from different universities where the research teams could not afford to have a bioinformatician in their team. So it was much easier for them to outsource the work to a company and get the work done.
And we have 2 more questions in the chat. So Eduarda is asking, what data types do you work with? And Aliona has a question about what was the most difficult task you worked on?
So currently the data type we work on is mostly NGS DNA sequencing. In the past, I've worked on ATAC sequencing, RNA-seq, and metagenomics. So a wide variety from all the different different industries and different fields I've worked in. So yeah. What is the second question? Sorry.
What is the most difficult task that you worked on?
Difficult task. I think for me it was trying to implement the. So I worked in. I'm sorry. So it was mostly this one project where it was the biomarker identification using gene expression data. And this was mostly in the drug discovery company. And we were trying to apply machine learning and deep learning into it. And that was absolutely new to me. So I was also looking at different YouTube videos and different courses on Coursera to understand what machine learning is. And Andrew Ng's course was the go-to. And yeah, so I guess that would be the hardest. Yeah, it's one thing that you'll never stop learning in most fields, and this is one such field. You have to keep learning the latest thing that's there.
Okay. So another question that I had was, as a programmer, because most of us are Python programmers, what depth of biology knowledge do I need to have, and how much of it rather?
I guess as long as I'm assuming in most cases you would be approached by a biologist with their question. So the first thing would be where they give you a very small introduction to it. And if you have absolutely no knowledge of biology, then they probably will try to explain it to you as they're talking to a 5-year-old. So that helps you. And you have to just understand what kind of data you're getting in. And once you understand their input files and understand how you would have to break things up, and they know exactly what they need, and so they will list out the requirements for their results. That helps you to build a pseudocode and easily go on with it. So a little bit of biology for sure. I mean, if you do not know the difference between DNA and RNA, yes, you have to read that up, because I don't think anybody is going to sit you down and explain that. But yeah, a little bit of biology is good to start off with.
Okay, perfect. And are there any challenges in bioinformatics that are very different from regular data science or machine learning from your experience?
From my experience, I don't think so. Not that I can think of right now over the top of my head. But yeah, I guess there might be. I'm sorry, I don't remember anything right now, but yeah.
That's okay. Any other questions, just drop them in the chat and we can, and then maybe we can ask other questions or ask you to unmute and clarify. Yeah. Floor is open for all questions. And remember, no question is a dumb question.
Yeah, that's very important. Yeah.
think that's all of my questions. And yeah. We can maybe wait for a minute or two and then we can go to the next.
I can cheat. I have a question, but it's at the same time it's tricky because it might not exist. But is there like a famous data set in your field? You know, like you have like the MMINST data set with numbers that is used like in deep learning. Is there like a famous data set?
I guess the famous data set would be, that is in R, and then it's slowly even pulled into Python, would be the IDIS data set in R. So it's just about the flower and the petal and the sepal measurements of the flower. And that's used as the most basic to try out different coding on the most basic bioinformatics data, I guess.
Oh, interesting. Thanks. So if there's no more questions, then feel free to ask them at any point in the chat. For now, we continue to our next speaker, Amanda Alvarado, whose research uses Python for the study of star-forming regions in the universe. So this is a topic in astronomy. So Amanda, if you can share your screen and begin when you're ready.
Yes, 1 second. So can everybody see my screen?
We can see your screen.
Okay, all right. So as it was mentioned, my name is Amanda Alvarado, and I'm going to be talking about Python in astrochemical research. So as a brief introduction about me, I'm from Puerto Rico, born and raised, and I did my bachelor degree in chemistry at the University of Puerto Rico. And in my last years of my undergraduate degree, I realized that I didn't want to do chemistry in the traditional fields that you would apply it to, such as medicine or pharmacy, and that basically space studies was the only thing that essentially blew my mind. So I decided to do a master's degree in physical chemistry also at the University of Puerto Rico, where I am currently doing research in astrochemistry. So as a brief introduction, astrochemistry is the study of the formation, destruction, and excitation of molecules in an astronomical environment and their influence on astronomical objects. Basically, astrochemistry is the study of molecules under space condition. And in research and astrochemistry, we aim to answer questions such as how, when, and where were these molecules produced, how complex is that chemistry, what is their role in that stellar evolution in space, and the biggest question and the hottest question is what role do they play in the formation of planetary system, and do they have a role in that birth of life or making the building blocks of life as we know it now? So what I do is I study the evolution of water molecules in star-forming regions. And for those who don't know what a star-forming region is, well, we know that space is made up of a bunch of gas and other elements. And as these molecules that are in space start clumping together and, getting together, they form what we call interstellar dust. And well, as time passes by, all of this dust starts clumping together and they start making a diffuse cloud, which is what we can see right here on the right. And as time passes by, that dust keeps clumping together and they form a denser cloud, which is what we call a molecular cloud. Now, in this molecular cloud is where stars are formed. And stars start as a protostar, which is basically a baby star that it's still feeding from that molecular cloud. It's still gathering all that mass and energy. And that protostars evolves into a younger star, which then becomes a planetary system, and then that star in that planetary system evolves, explodes, and then all that matter that was enclosed in that star scatters back into space, and then we get a diffuse cloud again. So what I do with my research is I try to study the abundance of water molecules in that molecular cloud. Here on the bottom, we can see the molecular cloud that I am studying is called NGC 1333, and it's a molecular cloud that has many protostars, and it's it has a lot of molecular and chemical diversity, which is why it's studied so much. And what I want to do is basically know how much water is there and the physical and chemical conditions that they are found in. Do they like to hang around near the protostars or more at the edges of the cloud, things like that. Basically, I want to know everything about water in that region. And the reason why my work is relevant, or it would have relevancy to future studies, is because water, as we all know, is a fundamental molecule in the universe, and it facilitates a lot of chemical reactions that are essential to that evolution of life. So I'm just trying to, put my grain of sand in and contribute to future studies that can answer the questions such as how does water behave from the more diffuse cloud to a planetary system, and then from the planetary system to life, essentially. So, okay, so I do astrochemistry and I study molecules in space, but how do I use Python? So the way I gather my data and obtain my data was that, we have the molecular cloud right here. And we know from previous studies that there are water molecules in that region. And those molecules absorb radiation from its surroundings, and they emit that radiation at a certain wavelength, which is what we perceive as light. And there are many space telescopes or Earth telescopes that can detect all of that emission, and they gather those signals from those molecules and images and just data from its surrounding, and it processes it, and that is what we obtain. We scientists obtain that. It's what we call raw data. And we take that raw data and then we use programs to analyze and process that data. So in my case, what I do is I use Python software packages for that analysis. And with that, I can create maps of region like this one. I can obtain spectra from the molecules that are there. And I can also make specific diagrams such as this velocity position diagram that I have right here, and many other results and things we can obtain from using those Python packages. So I know this might sound complicated, and the way I like to explain it is as a stereotypical serial killer crime scene, where we know that serial killers have behavior and some patterns, and in that crime scene, that killer, would be the molecules. Molecules have a behavior and a pattern. And as we know, we can obtain a lot of information from the crime scene. So in a normal scene, a forensic team would go in and gather fingerprints, clues, photos of that crime scene, and that would be the telescope. So we now have the serial killer and we have the evidence. And now those things are given to a detective, which would be the scientist, and the detective's role is to figure out what happened, what is happening, and what will happen in the future regarding those molecules. So the way I like to think it's basically solving like a mystery scene. And as any good detective, they have their own methods. And in my case, my method would be using Python in order for me to solve that mystery case. So what I use are open source Python packages for astronomy. A Python package is like a collection of modules and a core code that is written for a specific purpose. And that open source means that it's open for the public to see, edit, and basically just see the code, and they can edit and they know what's in that package. Of course, it has license and copyrights, but basically it's just a code that is shared between scientists, or it's published somewhere and anyone can use it. So for astronomy, there are many packages. As we can see, they're all made for a specific purpose, such as PySpec, which is for spectra, Gala, which is for galactic environments and modeling, I think, galaxies, if I am not mistaken. We also have, for example, GammaPy, which is Python to process data from gamma ray telescope. So as we can see, these are only just a few packages, but there are so many other packages that are used for astronomy. So the question is, which packages do I know to use, which are good for me, which ones I can edit? When you start looking to all of those little details, it becomes kind of like a little headache, and that is where AtsroPy comes in. So AtsroPy is a core package of Python that its main purpose is basically taking all of these packages that I mentioned earlier into one core package. So it's basically a library of astronomy codes that one would use to perform and analyze astronomy data. So it was mainly made for scientists, and that is why it's concise and a readable code. It's very like user friendly, so you don't have to know a lot of programming in order to use it. And the good thing about AstroPy is that it's complemented by general scientific packages such as NumPy, which is for multi-dimensional arrays, SciPy, which also uses matplotlib, it's to create visualizations in Python, and it has those affiliated packages that are made for specific functions in astronomy, such as the ones that I mentioned before, like ApplePy, GammaPy, PySpec. So basically, AstroPy is like an all-in-one product that actually works, and if you don't like it, then you can always edit it or use only part of it and then write your own code, which is why it's so great and I like it so much. So here's an example of AstroPy to obtain a line spectra. So this code was written for making a spectrum of this region that is enclosed by this circle, for example. So the first thing I do is I import the packages, and this doesn't have to necessarily be done. I know that you can use AstroPy with Anaconda, and you can just call AstroPy, and then you wouldn't have to write this, but this was my first code ever. So I wanted you guys to see that that in any code you can use many packages and put them all in one just specific code or file, and then you can run that, and that's super convenient. And then, well, here I put the coordinates and the radius of that circle that I want to obtain my spectra from. And here are some lines that I obtained from the AstroPy website. AstroPy has many tutorials and manuals and stuff like that, and information on how would you write that code in order to obtain any result that you want. And then here I use matplotlib in order to create this diagram. So I would run this very small code, and then I would obtain my spectra, which is very simple, and you don't need very extensive knowledge of programming in order to use it. So why would I use Python packages for astrochemistry, since we know that there are many other software programs that were already created for astrochemical research and to analyze data? Well, the reason why Python libraries are becoming so popular is because they're beginner friendly, as I said, easy to learn, understand, and use. They are very compatible with many platforms. Many software programs in astronomy are not. A lot of them, you can only use them with Linux or things like that. But with Python packages, you can use them on Mac. You can also use Anaconda, and you can use them on Linux, Windows, whichever you prefer. They're cost effective. I mean, Python is free, so that's super convenient. And the most important reason is that they're flexible, and they can be easily modified to each scientist's needs. Like I said, it's like an all-in-one product that if you don't like, you can just write a few lines of code for you to edit it, or you can edit the core code that you download and then use that for your own research. And for my research specifically, AstroPy has been the most useful tool for elucidating those chemical parameters from those molecular line emissions that were previously obtained from the telescopes. And AstroPy helps me obtain results that I will later use in order to, well, solve the mystery case, basically. So as a summary and key takeaways, well, astrochemistry is the study of molecules in space, and I study water molecules in star-forming regions. And we can use many Python libraries in order to process that data and analyze that data, and it's super user-friendly, and you can edit it, which is what makes it so convenient. And well, for the sake of this presentation, which is careers in Python, what I find very nice about this is that astrochemistry and programming go together hand in hand. So if you're either a programmer that likes space or an astronomer that likes programming, then maybe astrochemistry would be good for you, and you don't have to choose one of those fields. You could just do both. And I think that would be all. So any questions or comments that you have for me?
Thank you, Amanda. That was very nice.
Thank you.
Any questions for Amanda?
So we have some comments about the presentation and saying it was a very lovely presentation. I have one question about, so
yes.
Let's say I'm just programmer who doesn't know much about, who knows Python well, but doesn't know much about chemistry or astrochemistry. So where do I get started there, and how do I step into this field, basically?
Well, I would say you don't need a lot of, I would say, extensive knowledge, as long as, well, if you're writing a code for a specific research, then you would, of course, need to know like the theoretical background about that. But I think as long as you have knowledge of one of the two fields, that's either Python or astronomy or astrochemistry, then it would be easy to learn the other one. Um, as I mentioned, like if you're an astronomer and you don't need to know a lot about programming, you can be a beginner and you would still be able to use these packages. But if you're a programmer and you don't know much about astronomy, then you can just maybe meet up with an astronomer, read a few papers about it, and then start writing your code starting from there.
Okay. It sounds pretty doable.
Yes.
And
it's very nice and interesting. Yes.
We have one question from Eduardo about the data that you get. Just a second. Is the data that you work with available online? Is it hard to obtain, and how does it work?
Yeah, well, normally all the data that is obtained from telescope is made, it's published in the websites. For example, my data was obtained from this telescope right here, which is the Herschel Space Telescope, and they have a website, and all that data is available online. So um, my PI knew the person that obtained that data, and we talked with the person to make sure that that data hadn't been used and someone wasn't working on that data. And then when we made sure that nobody was working with that data, we obtained that data from the website and we started working on it. So it's very accessible. You could enter any website from the telescopes and check what data is available from previous astronomical surveys, and then start from there. I hope that answers the question.
If not, Eduardo, you can also unmute yourself and clarify.
Yes.
Abritej has another question. So first he says it's a nice presentation. Thank you. And his question is it possible to predict the formation of water via fusion, fission, other phenomena from emission spectra? And what kind of models would we use? Monte Carlo?
Yes, actually, there are many papers. Most of them are written by, at least the ones that I read, by Erwin van die Schook. I think that's how it's pronounced. And there are many review articles and papers that have been published about the chemistry of water in space, about the dust, about water in liquid state, and about ice, which is water in solid state. So there is information about all of the formation processes, whether it's from hydrogen atoms and all the conditions that are necessary in order to obtain those molecules. And what was the other part of the question?
The second part was what kind of models are used? Monte Carlo is one of the. Just
yes,
also
so,
if Monte Carlo is
yes. Yeah. So currently, after I obtain the spectra, I obtain that columnar density and other parameters, and I am currently using radix, which is for radiative transfer. But yes, I know many other studies that have used Monte Carlo. So after you use, for example, Python packages or in my case, AstroPy, and you obtain that preliminary parameters, you can then use them in programs such as Radix or Monte Carlo to obtain even more data about the molecules.
Okay, we have one more question from Kedma.
Yes.
Which new algorithms are you planning to learn?
Well, the one that I am learning right now, as I mentioned, I'm using Radix for radiative transfer. And yeah, that's the one I'm basically learning. It's also an open source code that was written also by an astrophysicist. And I think it's written in Fortran. So that's the one I'm trying to get a little bit more familiar with in order to understand the core code and also the theoretical background in order to get new results and ones that I can understand and interpret in a nice way, basically.
And another question from my end, maybe it's a little more personal. So,
Yes.
what inspired you to this research, and how did you get there?
Okay, so when I started studying chemistry, I didn't know exactly what I wanted to do, and I just knew that chemistry was basically the only science that I really liked. And I started, reading articles and such, just as you do in undergraduate studies. And I started learning more about space and astronomy and astrochemistry. And I started to get more associated with that. And yeah, I actually started mostly inspired me to do this research is that in Puerto Rico we have the Arecibo Observatory. So I figured that if I started going towards the path of astronomy, then well, we have a radio telescope, and there are many professionals and scientists there that maybe could guide me through that. And when I moved and started my master's degree, I met my mentor. She's an astrophysicist, and she actually works with star forming regions. So I didn't know much about star forming regions, and as I started talking with her, I thought it was such a basically beautiful field and what a beautiful science. And yeah, that's basically how I started, and how I was inspired, and everything came together, and then I started doing this. And I'm actually very happy with my research.
That sounds so inspiring.
Thank you.
Any
Any
more
other
questions? We
questions?
still have 5-10 minutes. Drop in the chat. And no questions so far. But yeah.
We can continue then, I think, right? With our next speaker. Thank you again, Amanda. That was great.
All right. Thank you
Super
all.
interesting. Thank you.
All right. Okay, I'll stop sharing. Thank you, everyone.
All right. So if you have any more questions, you can feel free to put them in the chat. For now, we want to welcome our final speaker for today, Dr. Katinka Gereb, who will show the role of Python in data science and use cases such as churn prediction, which seems to be to the prediction of if clients will leave a service. Katinka, you can please unmute yourself and begin when you're ready.
Yeah, thank you, Nancy. Let me just see if I can share my screen.
Sure.
Okay, can you all see this?
Yes, thank you.
Okay. So hello, and thank you for having me at your meetup. As Nancy mentioned, today I will talk about the role of Python in the data science life cycle, mainly focusing on personal experiences with Python. And I will also talk about tools that I like to use a lot. So I thought I would introduce myself first. So I currently live in Melbourne, Australia. I've been here for 6 years now. At the moment here it's almost 5:30 a.m. So we live in very different time zones, and that's why I have my sleepy face on. And here in Melbourne, I work at a cloud consultancy called Contino. We help organizations with their digital transformation, and I am a data scientist there. So this space bug here is our mascot, Maurice. And this here is my dog. His name is Cosmo. And I actually lived in Holland for 4 years before I came here. I did my PhD in astrophysics. So my research was somewhat similar to what Amanda does, but in a different field. And I think this was the first time I came across Python. So during this time, I started working on a project that involved creating a Python pipeline for astronomical data processing. So this is how I got involved with Python. And how did I become a data scientist? Well, actually, I would say data science and especially astronomy research have a lot of things in common. So first of all, the analytics aspect, but also coding, getting insights out of data, and even the machine learning aspect of it. So I think for astronomy researchers, it's quite a natural path to follow to go into data science. So why does a data scientist use Python? Well, here I'm listing all the high-level steps a data scientist does. So here we are doing data wrangling, so data cleaning and manipulation.
statistical analysis, visualizations, also build models, machine learning models, and deploy those models. And actually, Python supports this entire data science lifecycle. So it's really not surprising that Python is such a popular language amongst data scientists, because it supports the end-to-end machine learning development process. And actually, these tasks here build up the data science lifecycle. So next, I would like to dive a bit deeper and have a closer look at this. So I know this slide looks very busy, but I will try to walk you through it. So first of all, here on the left side, we can see the steps that a data scientist does. So we start with some kind of data ingestion, then do exploratory analysis. So here we will look at the data, try to get some insights out of it, then move on to developing machine learning models. But we also want to expose our insights to the business and get feedback on how we are doing, and then feed it back into this life cycle. So this will be a very iterative process, and this is where I would see the role of the data scientist to be. And then we have this right side here. So actually these days, a lot of the data science happens in the cloud, where we need to set up the entire infrastructure. We have to store our data and so on. And I would say this is something that a data engineer or cloud engineer does. Sometimes it happens that the data scientist does all of these, but I would say it's not that common, not just yet. And then in the end, we also have the business side of things. And actually, I think this is a very important step here, because in the end, we always want to make sure that we are delivering some kind of business value, that we are solving an actual problem. But also at the very end of everything, once you have a machine learning model in production, you want to do almost like user testing. So you want to get feedback, and you want to make sure that your product, what you created, is user-friendly and useful. So next, I'm going to walk you through this data science cycle here, or steps. And I'm also going to talk about a few Python tools. So the tools we're talking about are Pandas, Plotly, and scikit-learn. And this is not a comprehensive list at all. This is just a tool that I myself used a lot in the past. And yeah, please keep in mind, this is not exhaustive at all. But first of all, I use Pandas for data cleaning and manipulation. So Pandas is a really flexible and easy to use open source data analysis and manipulation tool, and it's built on Python. It supports reading and writing files. For example, CSV is a very popular format, but also other text files are supported, Excel, even SQL databases, and so on. It's label-based, which means that you can apply column or row level mathematical transformation. So it's really easy to transform the data, so transform the shape of the data set, add new columns, create aggregates, and so on. It can also handle missing data. It has group by options, merging and joins, and it can handle time series. And I know this is a lot of information, but next I will show you what a Pandas data frame looks like, and I think it will be easier to understand. So this is a Pandas data frame here. So it's basically just a two-dimensional tabular data set. And you can apply transformation to this on row and column labels. So basically, as a data scientist, I want to take this data set and create a machine learning model for it. And in this data set, we have the information of bank employees, so credit score, geography, age, and so on. And here at the end, we have this exited row. Oh, sorry. So exited 1 means that the employee quit. the business, and 0 means that they didn't quit. So basically you want to predict whether your employees are going to exit or not based on all these other properties. And I'm going to come back to this later, like how we do this. But first I want to talk about the modeling aspect of it. Because for building machine learning models out of this data set, I would normally use scikit-learn. So with scikit-learn, it's very easy and simple to do predictive analytics, and it's also very efficient. So it's built on NumPy, SciPy, Matplotlib. So it's a mathematical, statistical, and plotting tool at the same time. So it's really multi-purpose in that sense. And it's also open source. And it's pretty simple to use. You can write a decision tree model basically in 5 lines of code here. So in this example, we have the iris data set, and this is a popular data set that contains measurements of irises, so flowers. So they measure the petal length, width, and so on, and also the iris species. So for example, iris setosa, iris versicolor, and so on. And here we can build a decision tree, which is a machine learning algorithm. And here you can see how the algorithm makes decisions. So basically we have this tree structure of decisions made for the iris species. So it's really 5 lines of code. And then once you build a machine learning model, also while you are exploring your data, you want to create visualizations just to see, what the data looks like. And I wanted to mention this visualization tool called Plotly. So I came across Plotly a couple of years ago, and the reason I like it because you can create these interactive visualizations. So if you hover over the data points, you will see data popping up, but you can also create animations that you can see here. So it has interactive components like this slider at the bottom, and this way we are looking at how the data is evolving over time, but it has many other interactive components actually. And Plotly, I think it started out as a visualization tool, but it really grew into this whole Dash enterprise. And with Dash, you can build and deploy interactive web applications, built on Plotly. So dashboards, for example, as you can see here, and they look really nice. And you can spin these up, very quickly. And this picture really don't do it justice, and you should definitely check them out if this is something you're interested in. They are interactive, so a lot of fun to play with. So basically, until now, we talked about 3 different steps in data science, so data manipulation and wrangling, building machine learning models, visualizations, and online app creation. But there is more. So basically at the end of the development cycle, we want to set up our data science lifecycle in an automated way. So in a way that it maintains itself. And coming back to this visualization here, basically I would say the automation step happens in this side of the cycle. And I would even highlight these steps here. So first of all, you want to version your code, your model, and your data, because this way it will be reproducible. So whatever you create, you can reproduce it the later stage. This is important for auditing purposes, for example. But you can also set up a monitoring and alert system for when a drift occurs. So drift will happen either in your data or model, because maybe the underlying structure of the data changes. So for example, last year, if you remember, at the beginning, we were all, let's say, working in office building, just to take an example. And last year, when the pandemic started, when we started working from home, probably if you looked at the energy usage of this office building, you would see a very different behavior. So before, we would use a lot of energy, and when we started working from home, this energy usage dropped. So that would be data that a model has never seen before. So you have to account for new trends if there are new trends appearing in your data set. And this is the part where you want to retrain your model to include and to account for these new trends. So I would say MLOps is really about building trackable, reproducible models that work in a self-sustaining and automated way. And here we are really merging machine learning with development and operations. And here I'm really just scratching the surface of what MLOps is. There's a lot more we could talk about, but if you are interested in learning more, there are a lot of services in the cloud that want to do the end-to-end MLOps automation. So here I'm listing Amazon SageMaker, Databricks and MLflow, Azure Machine Learning. So these are just the ones that I am more familiar with, but I'm not going to talk about this in detail, but you can definitely check them out. And next, we will just talk about a few use cases, because in the end, what matters is that you are solving some kind of business problem. So I mentioned this before, and this is what brings value to data science, right? Solving business problems. So let's look at churn first. So what is churn? Well, churn means customers leaving or quitting a service. So for example, if you're canceling your Netflix subscription or unsubscribing from a newsletter, and we have seen this data set before, and here churn is this exited row. So again, here we had the information about bank employees, and we are predicting if they are quitting their job or not. So if they are churning or not. And we can build a machine learning model to predict the probability of leaving for each employee. And I'm not going to talk about exactly how you build a model. Any online course basically will tell you that. This is how you do it, by the way, with scikit-learn. It's very easy. And I want to talk about how you actually use the prediction. So once you applied that machine learning model, what do you do with the results? So basically, this is what your model is predicting. It's telling you that 65% of the employees are at low risk, or they are not really at risk of leaving the business. 32% are medium risk, and about 3% are high risk. So high risk means that those employees probably already churned, they probably already left. And this is here great because now you know that you don't have to worry much about 65% of your employees because they are really happy by themselves, but those 32% medium risk employees, they probably need attention. So basically you can now treat these three groups according to their risk instead of treating everyone the same. So you can personalize your offers or personalize, your solutions to them. And I actually have a blog post about this on Medium. If you're interested in checking it out, it's called Risk Profiling for Customer Churn Analysis. And this is my handle. And I will come back to this later. But after churn, the second use case I wanted to mention is clustering. So clustering is about finding similarities in data. So for example, here we have a collection of pictures and we run a clustering algorithm on it, and you will detect structures in the data. So for example, here we have dogs, we detect boats, here cars and vans, bugs, and I'm sure you can find, you know, other ones. And what happens here is that data gets grouped together based on their similarities. So for example, picture that all have dogs, picture that all have boats, and so on. And actually you could apply the same technique to your customers. So you can segment customers based on their properties. So just to bring all this together, I also want to talk about Customer 360, and I will come back to how you are using clustering and churn for this. So for example, when you have all kinds of data and you collect them into one place, you will get the full view of a customer. So you're bringing all this data together to create a single source of truth. And here we can look at different things such as sentiment towards your company or a product. We can look at churn risk probability, and we can use clustering techniques to segment customers based on how frequent buyers they are, who are the most valuable customers, and so on. And this is useful because knowing this information, we can tailor and personalize solutions to them and improve customer experience, increase stickiness of our customers. And since this is a series of career talks, I also wanted to talk about a few ways that can help you to advance your career. So again, this is something based on my own experience, because as I mentioned, I started out in academia, and then later I became a data scientist. And in between, actually, I did a lot of things to land that first industry job. So I did some online courses, you know, just to be more confident in my skills. I started creating my projects on GitHub, also participated at hackathons. And I do believe these things really increase my chances of getting hired. And actually, I landed my first data science internship through this hackathon. And I don't know where exactly I'm heading, but I'm also doing other things just to build my personal brand in the meantime. So I started my own podcast with a friend of mine. I started writing blogs and started, you know, completing certifications such as the AWS and Azure Cloud Practitioner certifications. And, you know, I'm not saying you have to do all of these things, but, you know, if something resonates with you, you can definitely try them out, because personal brand in general helps you to build your credibility, demonstrate thought leadership through your work. And these are just 6 ways I'm showing you, but I'm also sure, you know, there are more ways to do this. And with that, I would like to thank you for listening. So as I said, I have a podcast with my co-host. We discuss ways of learning, adapting, and succeeding in tech. So conversations around leadership, agile, recruitment, and so on. I'm also on LinkedIn if you want to connect. And I have a few Medium articles, some of that I already mentioned. So thanks for your attention, and let me know if there are any questions. And you may hear my dogs whining in the background.
We hear him. Is he maybe hungry or?
Maybe.
Thank you so much for the presentation. If you want to share like your tag or so, you can do in the chat, for example. If anybody has any questions for Katinka, super interesting, very useful presentation for sure.
Let me just look at the chat also.
Alyona has a question. What was the first data science challenge you solved?
Yeah, let me think about it. The first data science challenge. I think when I started my internship, so just to get up to speed, I started working with text data. So that was actually a very interesting project because I had to get some data. I think it was some kind of web scraping even. And I had to understand sentiment behind tweets. So really, Twitter has an API where you can extract data based on some keywords. So this was with a beverage company. So you would put in beer, beverage company, see what kind of text data you get back, what are the comments, conversations around this, and then understand the sentiment behind it. But that was more just like a toy project. But yeah, I think after that, I started working on churn right away. So that was with an actual client.
So Aaron also has a question about, is there a learning resource you would recommend? Aluna already put in a resource, but anything besides that you would recommend?
Yeah, so for example, something I didn't mention because I never used before, I know also Google has a really good description of what MLOps is. I'm not exactly sure about the tools, but yeah, besides the ones that I mentioned, so Amazon SageMaker, MLflow, also Azure Machine Learning, yeah, you can just check those out, and also Google. There are some really nice descriptions of what MLOps is about. Yes, Ankit is saying, not sure where I'm heading. Well, I think that's okay. You will figure it out on the way. I think a lot of it happens like that. You just have to start somewhere, build some kind of experience. At least that's how I approached it. Once you actually have a little bit of experience, it will be more clear to you where you're heading, and also you will have more choices. So I wouldn't worry about it just yet. Yeah, someone is talking about XGBoost. I did use XGBoost quite a lot. Yeah, I very much like XGBoost. I don't really use, for example, deep learning models. I think they are kind of an overkill for the kind of work that I'm doing because, yeah, it's just very simple tabular-like data sets. And usually, for example, deep learning you would use for images or text data. But for the kind of work I'm doing, I usually compare, XGBoost with, random forest or linear regression. So I like to start usually with something very simple and explainable. So start with something like linear regression, where you can visualize, coefficients, understand what is having an effect on your predictions, and then move on to something like XGBoost, where you have higher performance.
So we also have three questions. So what influenced you on going to industry? What influenced you to going to industry instead of continuing in academia? And yeah, maybe you can answer that and then we can come to the next one. Let's take it one.
Yeah, sure. Well, that's a good question. I don't even know where to start with that. I think for me, one of the main reasons was I wanted a little bit more stability in my life, if that makes sense, because with academia, so at least in astronomy, you would have like 2 to 3 year positions, and then you always have to chase the new one. You always have to probably change countries, move to a new place, start a new life. And I just didn't want to do that anymore at the beginning of my 30s. And since, data science was very similar, it's something I was interested in from the very beginning. So when I heard about data science, I was like, oh, wow, this is really cool, because I really enjoyed research and the analysis side of things. So I was like, yeah, I could actually do that in a different context. So it wasn't a very easy decision, you know, changing careers probably never is, but it's quite normal these days, I think. So yeah, in the end, you just have to understand, you know, how exactly to make your move and do a bit of research on, you know, how you can upskill. And yeah, in the end, I'm actually very happy with my decisions. I'm really enjoying being in the industry. So I think it was the right choice for me. Well, data ethics, or have I worked on projects in which ethics toward was considered data privacy? So not exactly. I wouldn't say I applied ethics in my work. Let me think about this. I just actually completed a ethics course. So there is a really nice called Practical Data Ethics course by fast.ai. If you want to check that out, and that will tell you so different topics that I remember. So disinformation, bias and fairness, privacy and surveillance. So I think where I could apply it in my work is mainly the bias and fairness aspect of it. So I haven't really applied it just yet, but after completing this course, I think I will definitely have this lens of viewing my projects, for example. And actually there are even tools these days that are being developed. So not so long ago, AWS released a tool, for example, what is it called? AWS SageMaker Clarify, I think. And it's supposed to help you detect bias in your data and your machine learning models, which I think it's really cool. And that's definitely something I will want to try out in my own projects, but I haven't had the chance just yet. Where do I spend most of my time if I look at the traditional data science cycle? So yeah, I think this will be no surprise, but maybe mainly in the data manipulation space. So usually your data is not very clean. You know, you have to deal with missing values, you have to deal with duplicates, and the challenge is really bringing siloed data sets together. So usually these are like in different systems, you bring it all together and you are trying to understand what are useful for your models, you know, derive new features. And yeah, usually this is what takes most of the development process. Well, thank you.
Is that it for the questions? Did you check the chats?
Yeah, I'm
Okay.
checking the chat, but no more so far.
Okay.
If you have any more questions, just drop it in now. I think we have plenty time right now. So.
We can also do the other speakers join in, and then we have two speakers that at least have in common astronomy, and the other speakers also science. So maybe we can discuss together, compare and contrast the careers. I also studied astronomy, by the way, and now I do, programming basically, but in healthcare. But I've done my changes in my career, so.
Yeah, you went through a similar career change as I did.
So Nancy, what spurred or inspired your career change from academia to industry?
Stability also. I didn't want to move to another country, and yeah, you could even hear it on the radio on my way to work. There's a lot of work on programming, on IT. So I decided, I always liked that aspect of astronomy. So I made that choice to grow up and stick to a career. So. And I'm very happy. I really like my job. I really like programming. So maybe if the other speakers want to join and chime in, we have some minutes left.
I think I have a question. Sorry that I did it this way. I was just tiring typing. Yeah, I think it's a question for all of you. So if you look back at the whole your career that brought you to the place where you are right now, what piece of advice can you give yourself at the start of this path? And it's a question for all of you three.
It's a good question.
That's a good question. I'm thinking.
Well, I can just, while the others are thinking, there's something that immediately came to my mind, so maybe I will just say that. But I think I've just recently learned to be a little bit less of a perfectionist, because I think especially as women, we tend to be, you know, we want to do 150%, like 100% is not enough. And sometimes you just really, like, you don't need that. Like even preparing for this talk, you know, in the past, I would really just like practice and practice and practice. I was like, okay, this time maybe I'm gonna practice a couple of times and then I will see how I go. So trying to be a little bit more easygoing about things and, you know, not worrying too much. Because yeah, even if you know, try your best, you will, you know, beat yourself up. After that, it's not really helpful. It can also stand, you know, between you and progress. So if you're trying to do everything perfectly all the time, you know, it will take longer, while in the meantime, you could already having feedback on it and actually improving. So yeah, that is my main advice, you know, try not to be a perfectionist and, you know, just give things a go and, you know, try to iterate in the next steps.
That's actually very good advice. Recently, I had a talk with my mentor, and she was like, well, we're women in a very difficult field, and sometimes we have to give that 150%, even if nobody asks us to, because we are representing this minority in a very difficult field. And I was thinking that it was unfortunate that all of my other classmates do not think like that because they are not, well, women. And yeah, I would also give that advice, like don't try not to be a perfectionist, and yeah, always remain, like, do what you like to do and do your best at it. Possibly, I think that would be my advice, because we women worry a lot about what other people would think, especially in a very professional environment. And yeah, so just basically like do your thing and do your best, and that will always be enough.
Yeah, I agree with that.
Cool. And for Parimala?
Yeah, I think mine, I do absolutely agree with the whole, with both of you, what you said. I feel that, I guess I would advise myself to research more, study more, because sometimes you think you know everything, but it's not even the tip of the iceberg. So it's good to learn more about something new that comes out, especially in your field, because you never know when you would start using that. And learn the different applications of a new, I don't know, something new that comes out. And yeah, read a lot of papers is something I would tell myself for sure.
I love this balance, you know, from one side, do a little bit less, take easy with yourself, from the other side, do more. So it's really good balance, I think, literally.
No, I think, you know, these things, they fit in together. So I'm not saying like, don't work hard enough, like, or don't work hard, like that's not at all my message. So I do believe, you know, continuous upskilling and really investing time in your own education, I think that's extremely valuable. And that's what I was also talking about towards the end, you know, with my 6 different tips. So I think there's definitely something that will help you along your career. All I'm saying is just like, don't take yourself too seriously. Yeah.
Sure. Don't freeze on progress just because you're afraid to fail to learn.
Exactly.
And just
exactly. Don't be shy to be out there and learn.
And don't beat yourself up. if
Yeah.
not go the right way.
I agree.
By the way, there was
working hard is still something we have to do.
yeah, but by the way, Amanda mentioned really interesting thing. Amanda just told that when I talk to my mentor, so I'm wondering whether all of you have a mentor in your life and which role this person actually played.
Okay, so my mentor is my PI. So of course, for my thesis project, then I obviously have to have a mentor. But I really consider her more like a, well, of course, a mentor in my academic career, but also in my mentor as a scientist. She also went through, I'm guessing, a lot of hardships because, you know, she's a woman and, you know, back in her time, astronomy was not such a common or popular field. So every time she gives me that piece of like life advice, I always take it to heart. So that's the role that she plays. She has played a big role actually in my academic development as a scientist.
Yeah, I don't really have official mentors, but I do have people that I can consider to be mentor figures in my life. So these are some like ex-colleagues who are also a closer friend of mine. I always find myself, you know, talking about challenges in my career, and you know, you can also talk to them on a more personal level. So they are really good at giving advice, but my approach is also I observe a lot. So I do have a few colleagues that I really enjoy working with, and they are more senior to me. So I try to observe and, you know, notice why do I like working with these people? Like, what are they doing that I would like to be doing in the future? I think, yeah, it would be better if you had more of a mentorship kind of relationship, but you don't necessarily have to make it official. I think not always. I mean, it really depends on the circumstances.
Yeah, that's true. I technically don't have a mentor, but I would say back in grad school, my PI was someone who helped me make my way through. And I still try sometimes to reach out to him about work, not work. Yeah, so it's not a very serious like a guide or mentorship. It's just like casual friends catching up, and then you do discuss science along with it. So, yeah.
Great. And also wondering for PyLadies Amsterdam members, for Nancy and for Bhumika, what about both of you as well?
So, for me, in my bachelor's, there was one professor who helped me a lot. So I still stay in touch with him and I look up to him a lot. So, in fact, my dream profession is what he's doing right now.
And what it is, by the way?
He's a professor and he's also doing academic research. So it's teaching and research, which is sort of the intersection of what I want to do as well. So, and right now, while I'm doing my master's, again, I just started my master thesis research. So the PI I'm working with, I really look up to her and admire her because she really knows her stuff and she knows the field inside out. So it's not been, I haven't known her for long, but in the 1 or 2 months that I've known her, I really admire her. So I see her becoming my next mentor figure probably.
Good. And Nancy, what about you?
Yeah, I hear the abbreviation PI, so principal or primary investigator, if I remember right. So I always remember, I do have someone that I still remember, Martha Haynes. She's a very good astronomer. She used the telescope in Puerto Rico. And indeed, like life advice sometimes is so important from this person who you admire their career, and they tell you, she tells me, I still remember where we were and what she told me. She said, boring is good. And she meant about astronomy observations. If the night is boring, then that means all the observations were taken and you can do your research. And I still say it to this day. I'm 39 now, and I say boring is good on a Saturday night. but fine. And what other mentors? Yeah, just I try to look more like as guides, people that inspire me, because not only do they have a nice career, but they seem like a good person. That's, I think, very important. And yeah, I don't have any names in my head, but usually I come to a job and somebody grabs me, and I admire that person a lot and learn from that person a lot. They're like a temporary mentor, say. And yeah, I don't have a mentor that's been for years, but it would be nice. But I think that's been my journey.
Okay,
So
thanks.
in the chat, we also have one question for all the speakers. How much more education are you planning to pursue or acquire? Or
I'm happy to
Okay,
go
so
first.
yeah.
No, you go, Amanda. You go, Amanda.
Look,
So
look
I
at this, ladies.
I want to be in academia. My goal is to be a professor and do like my own research. At least that's my goal for now. I might change. But yeah, after completing my master's degree, I would actually like to take maybe 1 or 2 years, kind of take a break from studying. And then I plan to do my PhD on astrochemistry, since I hadn't had any education that is specified to any astronomy or astrochemistry. I've only done pure chemistry. Then that's like my next step would be getting a degree that is specific to my research interest. So that's the next step.
For me, I don't know about education in that sense of the word. I sometimes think about maybe doing like a computer science degree. I don't know if it's worth the investment or not, or time investment mainly or not. It's still something I'm contemplating, but I look at, educating myself as something that I need to do on an ongoing basis. So even if it's not like an official education like university or something where you get a degree out of it. But yeah, I think since the world of tech is changing so quickly, like every second year we have a new tool, we have to learn new things. So I try to think about it as something that I have to do on an ongoing basis, and not something that I've done once and I'm done with it, right? So if you want to also advance your career or you stay up to date, just up to date, continuous learning is something that will definitely help you get there.
Yeah, absolutely. Continuous learning is the key in science. So a few years ago, I did think I would want to do a PhD, but now I feel, I guess, with just studying as I work, that's the work. So I don't think I have the time to put into a PhD. So that is something that's now out of the window. So yeah.
so another thing that Amanda said kind of caught my eye, or ear rather. You mentioned that we're all women in science and we're a minority and we have different challenges. So it was just something I wanted to ask everyone. What kind of challenges have you faced and how have you dealt with it, maybe? So just advice that you would give to all the ladies.
Yeah, so in my case, well, I studied and still doing my master's in pure chemistry. And I feel like chemistry is just a very competitive field. So I did receive, not, I wouldn't say judgment, but a lot of questioning as to like, why do you want to do astronomy? You're already prepared to do, like chemistry or maybe medicine and pharmacy, go to industry. Like, what job will you have? Really, what will you do? Things like that. So I feel like it's very important, like that self-reassurance that this is really what you want and that you are completely capable of doing. And like, that is what you want to pursue. And for me, it's like that reassurance that I really wouldn't like to work with something in medicine or, you know, this common fields that a lot of chemistry is applied to. So I would say like just self-reassurance and make sure that what you're doing is what you really like. And if that's not what you like, don't be afraid to change your career or change it up a little bit.
That's golden advice. Thank you so much. And Katinka and Pari, what would you advise?
Well, I've never really looked at myself as just being a woman. You know, I never really think in those terms. I think more like, where are my skills? You know, how competitive I am compared to everyone else. But we do come with our own biases. So probably since I'm a woman, you know, I will see this in a more biased way. So for example, just when applying for jobs, you may have heard of these statistics. So I think as women, we tend to apply for a job if we think we have 100% of the skills. Men apply when they have 60% of the skills. So, you know, just understanding where our biases lie, I think that was something very useful for me, because I never really saw myself, you know, just being as a woman. Like, I don't know exactly why, but I never really thought, you know, I was disadvantaged just because of this. But I've also always been very proactive. So I really try to be, you know, speak up, or if I have anything to add, just do it. Like, don't be intimidated. You know, feel free to shine. I would say, like, feel free to show who you are and demonstrate your skills and so on. So, you know, don't think of yourself as you are behind, because you are really not.
So I did my bachelor's in biotechnology, and back in India, it's considered as a subject that mostly women take and not men. And in my class, I don't know, it was surprising that we had the same number of boys and girls in class, and the same in grad school. So you were always told that biology and anything with biology is a subject that women consider rather than men. And it was reassuring to know that men are also interested in this subject. And it didn't matter, like gender didn't matter as much in choosing what you want to study. I have friends who are doing their PhD in cancer research who are both male and female. So I never faced any backlash of being a woman in biology. So I don't know if this is a very useful answer, but yeah, this is what my experience has been.
I hope all fields get there soon. But Aliona and Nancy, anything you would like to add, share?
Nancy, go first.
Fine. I'll try to keep it civilized. I've been often the only girl in the room, in the meeting, and I just sometimes then if there's any obstacle, sometimes it can be just psychological purely. So I just try to not think about it. That works for me. That doesn't work for anybody. But when you are in the afternoon, you have a pizza session in a room full of guys and pizza, you know, just don't think about it. If you find it interesting, then do it. I mean, I had one pizza session, and my boss presented the Google Cloud. That was the first time I saw the Google Cloud platform. And I was, wow, I need to learn that. I found it super interesting. I started with all these ideas, how websites were deployed continuously. And I liked it. So for me, that worked, just putting it off of my mind. And indeed, in some fields, it's more balanced. And I think that ideally that should be the case, because, right, it helps productivity, and it's been proven. So yeah, that's my experience.
Cool. I think I will take on it from a little bit different perspective. It's easy to speak to me because I'm the person who's always looks at everything from the position of power. So for me, it doesn't matter who you are and who I am. If I know that I have a power, I will do it, I will speak up, and I'm also a really, really proactive person. From another side, for example, right now I'm facing some issues. I'm working for a company and we are looking for talented data engineers. And we are ready, let's say, to relocate talented engineers with experience from any point of the world. So for us, it doesn't matter where you are. And of course, I told our recruiters that the most important thing that I want to see at least 50% ratio of the candidates. And it's really hard to find literally female data engineers. Although for me, you know, like it's just data engineer, just a position, that's it. But what I noticed mostly, a lot of recruitment happening based on the LinkedIn. So just like a piece of advice for all of you who want to change your career or who wants to do something, first of all, take a look what you share on the LinkedIn, how your profile looks like. If you're a student who wants to do something more, don't say that I finished millions of courses. Show what you've done. So that's the good idea, to share the GitHub repo or to share your GitLab or Bitbucket, whatever repository you're using. Show what you've done. Or if you did something on Kaggle, show it. And I think that's most important. And if it's about, let's say, your profile that you're building up, also make sure that you have enough connections, that you follow the proper people. So I think that's the most important part to showcase. And yes, from one side, I know that me and there are a lot of people who really wants to see more female developers in the field. It's really, really hard to find because they're just hiding. I don't know where. I know that they exist, but they're just hiding. And it's really hard to find. So please take a look at your LinkedIn profile tomorrow morning to make sure that everything that you've done in there. And for those who are switching career, I see that a lot of people actually who done PhD in some specific fields like chemistry or this like biology, when they want to make a career switch to data science, they're starting from, oh no, first I need to learn how to program, then I don't know what to do. Don't look at data science programming jobs, look at the jobs that are intersection of your knowledge. So if you have a PhD or a master degree, for example, in astronomy, looks at the position with intersection of it. So don't start to, don't start to try to predict churn of the customers, but you can start working from your knowledge perspective. And I think that's the most powerful, because we have a lot of talented people that just with some education can work with these data sets and can do more than just a data science with a lot of programming experience can deliver, because he or she doesn't have any knowledge of this field. So take advantage of it. And I think I need to stop right now. And I see there are more questions. So let's get to the questions. We don't have a lot of time left.
Yeah, I think we can take this question and then
yes,
can call it a night. It's been a lot of information. So aside from stability, what other factors played a role in deciding trajectories for your careers for you?
I think this is something that Amanda mentioned before, but basically, what is it that excites you? You know, what is it that makes you want to get out of bed in the morning? I would say almost. So if you're passionate about something, that's definitely gonna help you, you know, to excel in that field. Because if you're really bored, you know, at work, you're unsatisfied, that's not gonna help you. So don't try to chase, you know, the money. If you are passionate about something, that will come along the way. So I would say chase whatever you are passionate about. So I like really, you know, digging into data, finding those insights. It gets me, you know, really excited to understand, you know, take something raw and make something out of it, something that's useful for someone. And that's what motivates me. But also, you know, along your career, you might find that, okay, sometimes you're in a technical role, but if you want to progress, in a more senior role, you will have more leadership responsibilities. So maybe you have to develop more of your people skills, like how do you lead teams, for example? Is that something that you're enjoying? Do you like working with people? So you have to understand, what is it that you enjoy? You will not always know it at the beginning of your career. Sometimes you just have to put yourself in those shoes and see, is it for you, is it not? So that's the best way to find it out, like really just start doing things. And yeah, try to chase what you're passionate about.
In my case, since I'm basically just starting my career, then stability, it's something I will maybe want when later on in life. Right now, what I'm looking for is mostly like, where can I learn more about the things I'm passionate about. In this case, would be astrochemistry. So I would follow that trajectory that it's more convenient for me. But also something that also influenced all of my decisions is that I personally don't like very competitive environments. I like more collaborative environments. So I don't work well under like that pressure of competition and who's better and things like that. So I figure that in my trajectory, I would choose environments where I feel comfortable in, and that I also would learn a lot. Those both are key for me to decide what I'm going to do next.
Yeah, those are really good advices. I guess for me, other than stability, one thing I looked at was when I was in academia, I wanted to see how it is to work in the industry. So I decided to switch. And I feel sometimes people are scared to switch back and forth. There's nothing wrong with switching as long as you are enjoying what you're doing then. And if you feel you want to learn something more, I started learning machine learning in the industry because we wanted to apply it there. And that's when I just started studying and looking up videos and learning. So again, it comes down to whichever industry you're in, just learn as much as you can, and that helps you get a good foothold, and you can then move around, and as Amanda mentioned, you can collaborate with the industry or with academia. That's always a good thing.
Sometimes you can learn something new within a company and just say, talk to your boss, your manager, and ask, I see this interesting machine learning project. Can I do that? Or some data engineering project and do that. And then you still have the stability of your job and you're still learning, right? I always have a folder in my laptop, in my work laptop, lifelong learning. And I'm always learning something. And I think until my last days that I can still read or listen or watch a hologram, then I will be learning, I guess. So that's it for today. Our time is up. Thank you very much for the speakers. The one from Puerto Rico, Amanda, Parimala here in the Netherlands, and Katinka in Australia. I don't know if you're going back to sleep. Thank you very much for waking up. And the rest of you, thank you for being here. Thank you for your questions. It was very nice. I hope it was useful for everyone and that you learned. Have a nice evening. And I will leave you the link to PyLadies Amsterdam. So if you want to join our next events, we already have planned some next events, and it will be hopefully also very useful. So there you can keep track of our events. Again, thank you, everybody. Have a nice evening.
Thank you. Bye.
See you.
Thank you.
Thank you.
Bye.
Thanks.